forest and conifer amount around stopover sites matter to migrating songbirds, not in the ways we think. Let me begin by introducing a bit of bird migration drill and terminology. Survival of migratory birds depends on having adequate habitat throughout their life cycle, on breeding grounds during the summer, during migration, both in the spring and fall, and on non-breeding grounds in the winter. The importance of stopover habitats, where migratory birds stop to feed during migration, has been little studied. These stopover habitats can be important for birds to rest and fatten up before they continue their migration route. Forest cover may be an important factor in stopover site selection by migrating birds for habitat or food resource requirements. Once birds land at a stopover location, they may fly certain distances to forage or explore for more suitable habitat. The surrounding forest cover may be important to birds even before they land, as they try to find suitable habitat and evaluate the landscapes below at certain landscape sizes. The landscape sizes that matter to birds are also called scales of effect. If these scales are assumed to be round, or the surrounding landscape is assumed to be equally relevant in all directions to birds, like shown here, then the scale of effect can be measured as a radius. Tree type, notably deciduous or conifer, might influence stopover site use. There are various differences between deciduous and coniferous forests in insect abundance and food resources for birds. Some studies observe that caterpillars emerge later and are less numerous in coniferous forests than deciduous ones, and that this may explain why some songbirds mostly forage in deciduous trees or forests. Caterpillars are present during spring migration and summer or breeding season, not during fall migration. In late summer or early fall, it could be that deciduous trees still host more insects than conifers and supply more berries or nectar for some birds. Unlike finches, mostly diurnal migrants, most songbirds are not equipped with specialized beaks to easily maneuver coniferous cones for seeds. There are at least 3 different types of flight habits for birds. They can be residents, those that stay home like most of us right now, and they do it year-round, like chickadees and nuthatches. They can instead be diurnal migrants, those that migrate during the day, like crows and finches. Our research focuses on songbirds that are nocturnal migrants, those that migrate at night, like most warblers, sparrows, wrens, among others. Migration is a costly process. Birds could be predated or not have enough food resources to sustain their long flights. Some of the few advantages of migrating at night are that birds can maximize foraging time and energy or fat deposition during the day before takeoff and the whole day after landing. They can also avoid predation and decrease exposure to adverse atmospheric conditions, like wind. This may explain why the majority of songbirds are nocturnal migrants. On the other hand, migrating during the day can be beneficial to locate suitable stopover sites for immediate energy gain or for birds that fly and forage at the same time. Our study aims to evaluate the influence of the surrounding forest on stopover site use by migratory songbirds in the fall, and determine the spatial extent or scale at which the influence is strongest. Specifically, we tested whether the activity of night migrating songbirds at stopover sites in southeastern Ontario, Canada, were positively or negatively related to the proportion of surrounding landscape that was forested, namely the percentage of landscape in forest. We also suggested that they could be negatively related to the proportion of that forest that was coniferous. To assess the influence of the 2 landscape variables, the percentage of landscape covered in forest and the percentage of forest that was coniferous, On bird activity at stopover sites, we selected 41 forested sampling sites in southeastern Ontario, Canada, with varying degrees of high or low forest cover in surrounding landscape. The forest cover varied within a scale or radius of 1 kilometer, so the smaller circle on the map, and 5 kilometers. We did our best to ensure that there was no significant correlation between the forest and conifer variables at these two scales. We then set up SM4 autonomous recording units at the center of each of those sites and left them to record from mid-August to end of October 2018. After we brought the recorders back, we used Raven Pro, the software, to listen to recordings and count calling birds as an index of stopover site use. At minimum, every 6 days of recordings, we sampled 1 minute every hour from sunrise to 7 hours after, for a total of 8 minutes per day. We used various pointers to not double count individuals within a minute, like pitch, intensity, frequency, and overlap. We were able to obtain data from 37 of 41 recorders due to various technical or human misadventures. We then fit a general additive model, or GAM, using the number of calling birds as the response. We fit the landscape variable of interest and covariates including date, time of day, and site. Here we can see how the mean number of calls per minute varies by date and by time, each dot color being a site. We fit this model at all landscape scales and extracted the R-squared and p-values. Plotting the R-squared and p-values at all scales between 0.5 kilometers and 15 kilometers, we can find the scale of effect. This scale would ideally have the highest R-squared and the lowest p-value. For the variable forced amount, the scale of effect was 2 kilometers, and for conifer, it was 8 kilometers. The surrounding proportion of forested landscape within 2 kilometers of sampled sites influenced bird activity the most. The curve on this graph and its confidence bands show the predicted number of calls per minute versus forest amount, excluding covariates, and the points are observed means per site. Bird activity peaks at around 55% forest. The surrounding proportion of conifer within 8 kilometers of sampled sites influenced bird activity the most. Same kind of plot, and it's clear that conifer has a negative influence on bird activity. Now what? This work is only halfway done. There are still tweaks to do and information to dig out. Having said that, we might be able to speculate a few things. Is the peak we found because birds concentrate less at higher proportions of forest in the surrounding landscape? What about the scale of effect? Is it that when birds fly over landscapes, 2 kilometers is enough for them to say, "Yup, this forest amount qualifies as suitable habitat. Plenty of room to find a safe resting spot." However, suitable habitat when it comes to conifer amount seems to influence birds much further away. Are these birds perhaps willing to evaluate that large an area or travel that far after landing to ensure that there are non-coniferous trees and hence more food? Perhaps most nocturnal songbird migrants prefer deciduous forests, looking for easier energy gain after resting the whole night. Gains that involve more insects and berries and less maneuvering conifer cones for seeds. Studies have shown that conifer deciduous tree diversity does increase bird diversity, at least in urban landscapes. We cannot deny that maybe these birds can, to some degree, make use of conifer resources like berries and shelter. To effectively conserve fall stopover habitats of these birds, we may want to look into ensuring that within a 2-kilometer radii of these sites, at least half or so of the landscape remains forested, and that within a much larger radii, conifer trees are not overwhelmingly abundant. Of course, we may also want to expand our study to other landscapes or geographic locations. What do you think? That's it, folks. Thank you for being here. Let me know if you have any questions, feedback, or just want to say hi. I would appreciate any kind of insight. Stay sane, stay safe.